Well, it's my pleasure to introduce Bill Allie. He was a member. He's been a member for a long, long time, back in the '90s when I started in the '80s. But anyway, I think he's been around since the '90s at least, and he's been kind of quiet lately. I think because he was working evenings and couldn't make the meetings. He used to give us some excellent presentations. Gave us presentations on things like Postgres and Java struts and all kinds of neat stuff. And tonight he's going to tell us about the Go programming language. And I think he's got a pretty good presentation laid out for us. So, Billy, are you ready? I think we're going to let you take it. Is he there? There he is. All right, I'm going to be quiet now. But I don't hear Bill talking. I see his slides. Bill is muted.
Okay, am I on?
There he is.
Yes. Okay, I'm going to talk about Go. It's a language I've been playing with for the last couple years. I found it as a really interesting language, in my opinion. It started in 2007 and has been developed at Google, primarily as a systems language to help them with some of their issues that they have. Yep. My phone recognized I said Google and was asking me what I wanted to do. So I'm going to be going through a presentation that was developed by someone else who did a pretty good job, probably as good as or better than I could. So we'll get started here. First thing we'll talk about is why Go. Go is a statically typed language, are efficient but bureaucratic and overly complex. Dynamic languages can be easy to use but are error-prone, inefficient, and break down at scale. Concurrent programming is hard. You got to worry about threads, you got to worry about locks, and it's just one big headache. And usually with other languages, you can pick speed, or you can pick reliability, or you can pick simplicity. You can pick two of those, and sometimes just one. And the question is, can we do better? What is Go? Go is a modern general purpose language. It was originally designed as a systems language, but that confused people. And it turned out to be a very good general purpose language. It compiles to native machine code, 32-bit or 64-bit, and ARM. And that 32 or 64-bit x86 is both Windows and Linux. It also compiles to iOS, and other languages have been added. It's statically typed. It has a very lightweight syntax. It's got a simple type system, and it's got concurrency primitives that make writing concurrent programs easy, or at least easier. Some of the tenets of Go's design was simplicity. Each language system should be easy to understand. Orthogonal is, I always have pronunciation with this word. Orthogonal. Go's features should interact predictably in consistent ways. Readability. What's written on the page should be comprehensible with little context. In other words, you can't write stuff that you can't go back and understand what you wrote earlier. It's a quote from one of the designers. Consensus drove the design. Nothing went into the language until Ken Thompson, Robert Griesemer, and Rob Pike all agreed it was right. Some features didn't get resolved until after a year or more of discussion. Of course, you have the Hello World program. In Go, it's basically you have a package main. You import the format package. And then you have a function main where it says format println hello and world. Here's Hello 2.0, where it's actually delivered over the net as a web page. You import format in HTTP. You have a function handler where it's passed a response writer and request, and then it prints to the response writer hello plus what's on the URL path. And in your main function, you have a handler which handles the root and calls handler. And then you start up the listen and serve process. So that's all it needed to create a web page that will print out hello world for you. It has a simple type system. Always statically type, but type inference saves repetition. In Java, you say integer I equals new integer 1. In C and C++, you say int I equals 1. In Go, you can simply say I colon equal 1. You can say pi is colon equal 3.142, which is a float. Greeting colon equals hello boot camp, which is a string. And mul is colon equal a function. In Go, functions are first-class objects. They can be assigned to variables. They can be passed as arguments and so forth. You can have types and methods. You can define methods on any type. Here we have a type point struct, which is x, y, which is float. Then you have a function with a p point, absolute, and returns a float 64. It returns math.square root p.x times p.x plus p.y times p.y. And you can say p is a new point, a type point, and you can go p.absolute and it returns, in this case, 5. You can, and you have type methods. Again, you can define types on any type. You have a myFloat. You do a function, absolute, with passing in a myFloat. And then you can f equals float 64m. And then if f is less than 0, return minus f or return f. Then you can define a myFloat and then call absolute on it. Go objects are just values. That's it. That's a Go object, or just values. Go has interfaces. Now, interfaces specify behaviors. They don't do anything. They don't define data. All they do is define methods. So here we have a type absolute as an interface. This defines an absolute function, which returns float 64. Then here you can type that implements those methods, implements the interface. You don't have to say, like in Java, you have to say this thing implements something. Here, as long as the defines a method for absolute, it satisfies that interface. So here they have a function print abs and pass it an answer, and then format prints absolute value and calls a.answer. So you can do print absolute myFloat minus 10 and print absolute point 3, 4, and it will return the absolute value for that. Now you may have noticed that myFloat and point have different types. So this is kind of sort of like a generic in other languages, but it's not. But it lets you pass it, as long as it meets that interface, you can pass that value in. So types implement interfaces implicitly, and there are no implement declarations. Now here's some interfaces in practice. There's an IO package in the standard library. and defines an interface called writer. And the writer defines a method called write. And you pass in a slice of bytes, and the writer returns how many bytes were written and an error, if any occurred. In Go, functions can return multiple return values. There are many writer implementations throughout the standard library and other Go code. We've already seen an example, function handler, write response writer. The format printf takes an IO writer as its first argument, and the HTTP response writer implements the write method. The format package doesn't know about HTTP, it just works because it's being passed to writer. And Go has good support for concurrency. In Unix, we think about processes connected by pipes. You know, you can do a find of the source package, grep, pipe it to grep tests.go, and xargs wc-l. These tools are designed to do one thing and do it well. The Go analog is Go routines connected by channels. Now up in here, this can be concurrent or it can be sequential depending on how many processes you have in the system and how many threads you can support. In concurrency in Go routine is done through Go, in Go is done through Go routines. Go routines are kind of like threads. They share memory, but they're cheaper. It's not, a Go routine is not a full thread. It's smaller, it has segmented stacks. And many Go routines can be assigned to an operating system thread. You start a new Go routine with the Go keyword. You have I being a pivot S, which returns a variable. Then you can do a sort of a slice. You do a Go sort slice from the beginning to I. You do the element just before I. And then you start Go sort S, I through the rest of the slice. And those two will run concurrently. They can be parallel if you have enough threads on the system to assign them to, but they are running concurrently. And as you may know, concurrency is not parallelism. Although it can support parallelism. In Go, channels are a typed conduit for synchronization and communication. The channel operator is a less than minus sign and is used to send and receive values. Here we have a function compute, which is passed to channel. It does some computation and sends the results to the channel. The direction of the arrow is the direction that it's sent. So here it's sent from some computation to the channel. In the main routine, we make the channel, call compute, and then we read the channel into result. So here it's from the channel into result. And here type inferences makes the result be an int because the type of the channel is an int. So it just makes result an int and assigns the channel to it. Concurrency has synchronization. Let's look back at the sorted example and see how to tell when it's done. Like, how do you know that the Go function is done? Make done is you make a channel Boolean. Do sort, you have a function which does the sort of the passed in parameter. And then you send true to done when the sort is done. So here it comes to it calls do sort, then it waits for done to be done. It waits for something to be read from done, and here it reads again from done. Now, unbuffered channel operations are synchronous. The send receives happens only when both sides are ready. So what may have happened is the second sort may be done first. So it reads done, okay, it's done here, it's done, and then waits for the first sort to finish. Or the first sort can be finished first and it still works. And also we have communications. Common task is many workers feeding from a task pool. Additionally, work threads contend over a lock for work. We have a type, which is some structure, which has some state. You have pool struct, which is a synchronous mutex. And then you have a slice of tasks. And you have a function which is passed in the pool. And then it loops from for loop. It locks the pool, reads the task, next task, the first task to be processed, and removes that task from the pool slice of tasks, unlocks and then processes, then repeats. So it could start up multiple tasks and process them. But you have to lock and you have to make sure it locks and stuff like that. Here, Go and your many working Go routines receive tasks from a channel. So worker has in-out channel, which is the task. For task reads it from in, processes the task and outputs it. Then in the main, you have pending and done. You make tasks, you make your channels. Go send work pending. You start up a Go function, which is send work. So that's now running in the background, waiting on pending. Then you go through I1 to 10, Go worker pending done. So worker comes back right here. It's puts one, it starts out with 0, processes T with 0, and outputs it. And then it does consume work done. Where consume work does something with all the work that's being done. In Go, the philosophy of Go concurrency is Go routines give an efficient asynchronous model, but you can still write code in a synchronous style. It's easy to reason what write Go routines to do their specific jobs while connect them with channels. In practice, this yields simpler and more maintainable code. And think about Go and concurrency issues in the following manner. Don't communicate by sharing memory. Instead, you share memory by communicating. Go has a rich library support. There's more than 150 packages. There's more under development, improving every day. And many great external libraries too. You have MySQL, Mongo, SQLite 3 database drivers, SQL bindings, protocol buffers, OAuth libraries, and much more. You may have noticed that Postgres wasn't listed in the database drivers because that's built into Go. Go has a built-in Postgres library. What's good Go for? Initially, it was called a systems language, but a lot of people were confused by that. There was unexpected interest from users of scripting language, attracted by easy, reliable language that performs well. Diverse users across community, scientific computing, web applications, graphic and sound, network tools, and much more. So now Go is turned into a pretty good general purpose language. And this presentation has many other real world stuff. I won't go that, but what I will do is go and talk about GoDev. GoDev is where you go to get Go. You can download and install it. This out of the way. Here you can learn about Go. There's documentation, tour of Go. Tour of Go will give you a good introduction to the language, much more than I can give here. And you have Go by examples. You can view examples. You have your documentation. You have effective Go, Go users manual, the standard library, and release notes. You have packages. You can search for packages. And you have community, which you have Go blogs, Go project, meetups, conferences, and recorded talks. The recorded talks I found very good for learning stuff. The presentation I walked through was under the 2011 Real World Go. They also have writing web apps in Go and talks. And many other talks that are pretty interesting. Some of the ones like 2009 talk about stuff that has been changed in Go. But still, you can pick up good information from it. The best places would be, I find if you're just learning, is effective Go and looking through the standard library. The Go user manual is pretty technical, but it gives you good places to go through. And basically, one thing I want to do is go here. And I took one of the things that they had there, which was the Hello World that was set up as a web browser. Basically, it's package main, I imported. One change I had to do was I had to use net HTTP to get the HTTP functions. And as one aside, what I use when I develop Go is I use Visual Studio Code. And I also use Git Desktop. I don't know if you guys use Git Desktop. If you're using Git to manage projects, Git Desktop is really a good tool to use. So I have here, I basically, once I go in here, make a change, you can use Go. You can build the Go by doing, and should I make this larger text? Then you see it pretty well.
If you would, please, yes.
Okay, let's see, settings. Text editor. Let's see if this makes that 16. Is that bigger or do you need it bigger still?
I think that's good.
I'll make it 18. Okay, and then down here, let's see, cursor. I'm not sure I can make this any bigger down there. So what I'll do is I'll cheat a little bit. Is the text in that box big enough, or should I make that bigger too?
I think it's all right.
Okay. I'll leave that there. Make it a little bit bigger. Okay. So Go has a lot of different tools. And you say go, you can go help, and it gives you the commands that you have. You have go build, which compiles package and dependencies. So if I go build, period, it will build that program for me. And the executable is here, hello world. I have now started the web server. And if you go to define.mug.org/hello, or slash, and then type in there we go. I think I can go localhost. And it's on port 770. Couldn't use 8080 because I run something that uses that. And then type in whatever text you want there. And it'll come back with hello, Bill Allie. If you use define.mug.org, if you want to go there yourself, unfortunately, I won't be able to get to it because this is on my local network inside. Hopefully it looks like it did work. So if you want to try it, you can try it. I can leave it up and running. But I also have some other things. If I can take questions now here, if you have any questions.
Richard L., you had a question?
Okay.
Go ahead, caller.
Well, I have a question.
Okay.
Okay.
Tell me about capital letters and lowercase letters in structures and function names.
Okay. In Go, there is no public or private. You can't say private something to make it private. Let me go and bring up. How you determine private and public is with the case of the initial letter. this function test intent to engine, or let me go into an example here that would be. To make something public, it begins with a capital letter. If it doesn't begin with a capital letter, it's local. For example, engine layout is, in this case, is local. So is pro forma rotors. But TNT2 engine is public because it begins with a capital letter.
So that's enforced. That's not just a convention, right? That's actually
enforced.
Okay.
If you make it a capital letter, it's public. Make it a lowercase letter, it's private. For example, in TNT engine type, engine, left, right, counter key, and maximal states are all private. Now, that's outside the package. Inside a package, which is this TNT engine is a package, these are actually available to anything that's in this package. So it's only private outside this package. If I go to something that uses TNT2 engine, I can define something as a type 2 engine, but I won't be able to see what's inside of it because they're all private to TNT2 engine.
Okay, thanks.
Any other questions?
I've heard Go doesn't have exceptions.
It does not have exceptions. Everything is passed. It pass an error back, is pass it as a second argument.
Doesn't
Let me
that seem
go
kind of
ahead and-
backwards?
No, it's not really.
I see you're not collecting any errors in the code that we're looking at right now.
If there's errors that are occurring, because I'm calling stuff that doesn't actually return an error code. Let me go something where I do use errors. And that would be in filters. Okay, here's an example. These files that are here. I want CLib. No, I didn't want CLib. Let me close this. Okay, then current repository. I opened the wrong one. Okay, now I'm in the right one. What I have here is a bunch of filters that I developed when I was writing the TNT2 engine. Filters to do ASCII 85, base 64. Then there are filters in basically pipes. So let me go to one of them here. Here's one of them. And here we have IO copy. IO copy takes a destination IO writer, a source IO reader, returns how many bytes were written, and an error. So I defer. Go has a defer, so you can defer functions to the end. Here I call RW writer close. Then I call the copy function, and it returns an int with how many were written, which I really don't care about. So I put an underscore there to ignore it, comma, and then error. Then if error is not equal to null, I do a close writer with the error, failure copying IO from reader to hex writer. So that error is then passed along. Same thing here with from hex. Again, I capture the error and handle it. So you handle the errors at the time they occur. And if there's anything else you need to do, you can do it at that point. So as you're reading code, the error is entered right there, and it's not handled sometime later down in the code. But if you have to figure out what's happening with your error, you come down there and do it.
So the code looks like what you're trying to avoid instead of what it's actually doing.
I'm not sure I understand. The code, you're handling everything at the point where it's handled. So if you handle the exceptions, down exceptions, then you have a whole bunch of, when I wrote exceptions, you had, if this exception occurred, if this exception occurred, if this exception occurred. Do this. Here, you handle it when it actually occurs. There is a, in the talks I showed you, in GoDev, if you go to community, recorded talks, so they have some talk about exception handling or error handling. I don't remember the exact spot it was, but they do have it in here. So you can get more detail on how they handle errors
Sure.
and why they don't have exceptions. So that goes into more detail there. So, like I say, there's in these talks, there are talks on why they don't have exceptions, why they go with the error route. Oh, another thing that I didn't talk about in Go is they have something called the playground. It's where you can come in and type in different Go things and play with them. You can run them. You can type to try out things in here. So they have different ones that they have here. For example, they have the goal of life. You want to look through here, someone wrote the game of life in here. And you can see it running. And you can look at the different Go. But you can also type in your old code. If I want to try something to see how it works, I'll come into the playground and put the code in here and try it. Now this runs in a sandbox. And let's see here. They have like a concurrent primes sieve, but there's some of the limitations as the data always starts from a certain epoch. So there's many things you can do here. You can also select what Go version you want to run it in. Right now, it's either Go 1.21 or Go 1.20.
Would that be like a virtual environment?
Yeah, it runs on a server in a sandbox.
Okay. But that's for the Go playground.
That's for the Go playground.
Not for running your normal code in production. Okay.
No. You can also install your own Go playground on your own server, but it still runs in the sandbox.
Okay.
If you don't want to go to the Go playground here.
Sure. As I recall, I think you're a big fan of Python, aren't you?
I was a big fan of Python.
But not anymore.
If I'm going to do something, I'll do it in Go.
Oh, okay, that's what I was getting at. You're leaning towards Go now instead of Python.
Yes. And
Cool.
instead of, unless I'm forced to write it in Python, I'll write it in Go.
Okay.
But it's like I said, it's for me, it's a pretty fun language to write in.
Right. Now, forced to write it in a certain language, is that based on a client specification, or have you found things you can't do in Go that you have to revert to Python to get done?
I haven't really found that yet.
Okay.
And also the reason why I like it, it compiles down to machine code.
Yeah.
There's no virtual environment I have to, or interpreted environment I have to.
Okay.
And
now, you mentioned that it can compile for the machine code that it compiles down to. So on Windows, does it create an exe for you? Or I haven't done any Windows development in years and years, but it creates an exe. But you said something about it'll compile it down and it's for Linux or Windows, or do you have to choose at build time which one you're going to do?
You build it, you choose at build time, but you can also cross compile.
Okay, so if you're on a Windows machine, you can build a Linux binary.
Or or in my case, if I'm on a Linux machine, I can build a Windows binary.
Yeah, but you can't take your Linux binary and run it on Windows.
No.
I guess that's kind of okay.
No.
Okay, so it's you actually build a specific binary for that target machine.
Yes, in fact, you can compile the Raspberry Pi too if you want.
Okay, because it's ARM, and then there's Raspberry Pi. It's going to be Linux, right?
Yeah. But,
so you're on a Windows x86 machine building a binary for Linux ARM to run it on a Raspberry Pi.
Yes, you can
That's
do that.
neat. Yeah, that's pretty neat.
I prefer to
building
on
could do that for a long time, but you got to jump through hoops to make it all happen.
Yeah,
but
I mean, I prefer to do all my building on Linux for whatever target I'm going for. I built
for obvious reasons. Yeah.
And actually the machine, my Linux machine right now is a virtual machine.
Running under on a Windows host.
Yes.
Okay.
The
Good.
reason for that is when I bought this Windows machine, it was I bought because of the number of processors it had and the memory it had, but it was designed as a game machine. When I tried
Yeah.
putting Linux on it, it kind of broke it.
So you got a Windows machine. You're running
Yes.
VirtualBox to run Linux, and within the Linux machine, you're compiling Go to run on a Raspberry Pi.
Yes.
Or are you using WSL?
Using
Yeah, have
what?
you done that? Windows system, Windows system for Linux, or what is that? What WSL is? Basically running Linux stuff.
No,
Okay,
no.
so you're running VirtualBox and actually running a
VirtualBox.
Linux.
Yes.
What's your Linux of choice these days? You Debian?
I use Ubuntu, the latest,
Okay.
the latest long-term support.
Sure. At this point, it's 22. Yeah, 2204. But it's all built into the tool chain to do that cross compiling. And
Yes.
I mean, that's pretty powerful.
You set an environment variable of the target OS,
Mm-hmm.
and that's it. You run.
And then it spits out your binary that you can just
Yeah,
copy over to
I actually have an
another
IDE
machine.
called Light IDE
Uh-huh.
that will let you select what you're compiling for. As a
Okay, and that's an IDE built for Go.
No, it's not. It's designed to use for Go. Yes, it's Light IDE X, and it's for Go. But you can cross compile for
Yeah.
ARM5,
Nice.
ARM6, Darwin.
Nice. And that IDE is running Windows.
No, this is
Windows,
running on Linux.
Okay, that's in your virtual machine.
Yes,
Cool.
but I've not used this for a while because I've been using Virtual Studio
Okay.
Code.
Okay.
Like I said, I use Virtual Studio Code and I use GitHub Desktop,
Right.
which if you're not using that, I suggest looking into it. If you
Yeah.
do anything with Git,
Well, I do quite a bit.
so
But
GitHub
it's all
Desktop,
command line stuff.
yeah, GitHub Desktop is a pretty nice tool. It's available under Windows, it's available under Linux.
Yeah. Mac, that's what I'm running on right now. I imagine it's there.
I don't know, you'd have to look. Because I don't run with Mac.
John Gruber's got a question, by the way.
Through Go will compile to iOS. So,
Well, it's interesting. It would compile to iOS, but putting things on iOS is not easy if it didn't come from the App Store.
I think you can download Go for iOS. Let me double check that.
Okay.
John, do you want to ask your question?
Okay.
Yeah, I was wondering if the strings are for Unicode values or
Yes, they are. The strings are Unicode value. In fact, they don't have, they have a character type, but that doesn't do Unicode. They have a rune type for Unicode. So if you,
I missed the word. They have a what type for you?
it's a rune. It's called RUNE.
Ah, okay.
And rune is a Unicode character.
Ah, okay.
Okay.
And
Now,
then
back to playground. Let me go to playground again. If I go to the hello world, you can see Unicode characters here.
Oh, yeah. Okay.
okay, now I understand.
Yeah.
Okay, so it's fully supports it's UTF-8 by default.
Okay.
And if you were constructing a protocol, a network protocol buffer of some sort, you then would use a different type?
The Go does have Unicode protocol buffering, Unicode protocols, net protocols, but everything is a slice. So I'm not sure. I've not done that before, so I'm not sure how to answer that. But I'm sure you can find the answer on GoDev somewhere.
Okay, thanks.
Now, what I was showing before with the filtering, everything, the filters take like 2x takes a IO reader and it returns a pipe reader. So it reads everything from the IO reader and outputs it to the pipe reader. And basically it's copying it through. What it does down here, it takes an R reader and an R writer and IO pipes. And then I take a new hex encoder, which reads the R writer. So it returns a hex, an IO writer called hex writer. So to filter it, I just copy from R, which is my IO reader, and copies it to that writer. And it, it sends it to my R reader, which I return. Now, some examples of how to use this.
Before we get into that, I think Jim Peterson's got a question.
Okay.
Yes, I was wondering, is Go, the things you're showing here, it seemed to point to Go being used as maybe for writing small utilities, that would be used in a pipe and on a Linux
Basically,
command
you
line.
can, and you can do that. For example, I wrote an encryption program that will encrypt data.
Okay.
And
right.
I wanted to do things like output that data as a hex format, or output it as a PEM encoded.
Okay.
So that's basically why these filters were written. I also wanted to be able to compress the input data before I encrypted it.
Okay, so it sounds like is Go therefore intended mostly for writing small utilities that go in a pipe, for example, or that have input and output and do a specific function, or
it's a general purpose language. There are some pretty big systems written in Go. One I can think of is called HashiVault. I don't know if you use that, know about that.
No.
Canonical did a ton of Go, I think, in their Juju stuff. Wasn't a lot of that?
Yeah, it was used for a lot of things.
Yeah, like web applications and stuff, big things.
Yeah.
Okay, but what about like Rust is getting traction now in the area of the Linux kernel for more robust code? Is that what Go could also do, or is Go more like standalone applications, not kernel code?
It could be used in the kernel. It was originally designed as a system language to help Google do things in a more compact, easily to understand fashion
Sure.
to solve some of their problems.
Okay. So I've got a question. I see that the assignment operator is : equal. Kind of reminds me of Pascal. Wasn't that : equal?
No, that's to do type inference.
Okay.
So reader and writer is taking on the values returned by IO pipe.
Okay.
Type of IO pipe, which is IO pipe reader and IO pipe writer.
Okay, so that's given the value and the type when you do that?
Yes.
Okay,
But that can only
What's-
work in functions.
what's the equality operator? Is it equal or double equal?
The equality operator is double equal.
Okay, I didn't see, I see not equal in your code there, but, okay, so it's still double equal, like almost
Yes.
all.
So when you're
and-
not doing type inference, can you use equal for assignment?
Yes, let me go to show an example of that. That would be, let's go back to TNT. Let's go to TNT Engine. Oh, I was writing some documentation there that
Yeah,
got previewed its stuff. So let me go here and look at TNT Engine Go. Okay,
what, okay, go
here's like
ahead.
a constant. I'm defining constants within
Okay.
and I'm defining variables equals, and here's the type, and I'm doing some initialization here.
Okay, but does the variable internally know the type then?
The variable is being defined as a slice of rotors, pointing
Okay,
to rotors. Okay. So Go format rotors is a slice of rotors, and it's equal to what these values are being done here.
okay,
See, there's a bunch of stuff here. And here I'm defining a rotor as being equal to Go format, which is a slice of rotors.
mhm. So when you say it's a slice of rotors, would you think that's an array of rotors or a list of
A
rotors?
slice is built on top of a array
Okay,
base, but slice gives you different things you can do with them.
okay,
And here I'm saying a counter is a pointer to a counter equal to a new counter. New will initialize a counter to its nil values and returns a pointer to it. So a counter is just up here, as you can see at the type counter struct, defines an index as a pointer to a big int. A big int is a multi-precision integer. Basically can be as big as you have memory to allow it to be. And it's an exact int. And it can be pretty big. And then I define methods on top of them. But it's assigning all those that big int will have its null value, a nil value.
mhm.
And
Okay,
here
but counter is a pointer to an integer or a pointer to a counter.
yes,
Well, there you're creating a variable that is a pointer to a counter. So when you call functions, are you passing them pointers or
it's being
the
passed.
argument itself?
It's a pointer to a counter. It's being passed.
Okay. So if it's a pointer to the counter, can the function modify the value that it was pointed to? And
Yes,
it's actually modifying the value. So when you get out of the function, you still have the modified version of the value.
yes, because it's modifying what it points to.
Okay. All right.
Okay. So you can define vars. You have a var keyword. Now here I'm defining a bunch of different vars in one place, so I don't have to say var every time.
Right.
But in one of these functions, you could say var value, var name, type to define the var. Or you can just say var. But inside a function, you rarely use the var inside a defined function, because you can do implicit types. But outside a function, you notice this isn't a function, you have to use the var keyword. Okay.
So
So
the file suffix is .go. That's
Yes.
your source files. Okay, makes sense.
.go. And then I have here, you can do testing. I can run tests.
Sure.
I'm running the file tests, and they all passed. And I probably won't have time to go into how you do testing, but there's some good documentation on testing in Go. And it can generate these tests for you from this. There's a tool to generate these tests. And so you can have a function you want to generate tests. You can run the tests. You'll have to go in and modify them, but it generates the template for you.
Okay. So is the ecosystem really robust where you can, like Python's got a huge ecosystem. You got modules that'll really do anything.
Yes.
Is Python, is Go caught
Go
up?
has that, and it's growing.
Okay.
I wanted to write a command line interface for the TNT2 encryption. And one of the things I was able to find going here in Go Dev. Oh, by the way, here's a list of companies that use Go, and there's a lot more. But some of the things they're using, I can view all stories, but I don't want to get into that. It's a lot of stuff. And Learn Go, they had sections, guided learning journeys. They had a section on CLIs. And one of the things they pointed to was one of the CLIs that I'm using, which was the same one that was used in GitHub. And that's the one I ended up using. And they used to have it listed right here, but probably have to go to learn more. Right now, they've got this thing about.
So if some 19-year-old came to you and said, I want to learn how to program, would you steer them towards Go or towards Python?
That's an interesting question.
Time to wake up.
Hold on a second. My glucose alarm is going off saying your glucose is low. Okay, well, I know it's low, so give me it.
Go get a glass of orange juice.
Yeah. I would say it's a toss-up for me right now.
Okay.
There's a lot of getting started guides, new to coding.
Mm-hmm. Yeah, there you go, right there.
They have tutorials here, and here you can go to.
Huh.
But in Go, they actually have, in getting started with Go, there's a Go by example, and they also have a tour of Go where you can take a tour of it. And you can step through things here. You can go through and locales. The Go playground they talk about. Now you start talking about Go packages,
Mhm.
imports, exported names. They talk about what are exported names. They talk about capitalized
Mhm.
and lowercase. Go functions. And you're asking about Go modules. There's a packages, you can search for packages.
Ryan Allen has a question on YouTube. Question is, are there standard mechanisms for organization / structuring of large multi-file projects? I'm thinking of things like Java packages.
Go has a package systems. For example, when I was talking about this program, I have filters. Let me go to TNT. You have Go mods, which talks about the modules that I use.
Hmm. It's like a
Entries.
manifest or something, kind of.
Kinda, it's in here in TNT Engine. I have a bunch of imports. Encoding, format log, math, OS are all included in Go, and strings are all included in Go. Then I have a JC1, which is a package I have, since I'm a GitHub COBOL, and a golang org, X crypto, and a SHA-3 package. Now for this one, that's all I have, but for the TNT engine, I have more. And I also have the TNT project, which has a Go mod that is a lot more extensive.
Hmm.
Okay, the ones up here are implicit. The ones down here are reference, implicit. Or these are ones explicit and these are implicit.
Hmm.
So there's a whole bunch of things that get referenced. And they have some things for here for like example, check for upgrades. I can check for upgrades to see if there are any upgrades. And I can do upgrades for explicit and implicit things. They also have a tool called Go Mod Tidy, which goes through and cleans up this file. Then they have sums, which is a very large file, which gives you checksums for all the things you're including.
Make sure you got what you think you're getting.
That's right. And you notice each one of these has a version associated with it.
Yeah.
So
Do you have to, or is there a way to just say, just always give me the latest version?
you can say get it to your latest, but once you do that, it's implicit that one version. And that version won't change unless you check for upgrades.
Oh, okay.
So this version I'm using, SPF 13, I'm using Cobra, is the one I'm using for the command line interface.
Hmm.
So if I go here, let me stop the hello world. I don't know if anyone went to it, but then I have TNT2 help. So it gives me usage statements and help statements. So if I TNT2 encrypt, by the way, using CLI, I can also have command line completion added. Oops. So here's the help flag. I can do things like use ASCII 85, use PIM. If I don't use either of those, it's binary output file format. So let's see here. What have I got in here? Give me one moment. I'll be right back.
Mhm.
While he's out, just a quick reminder, if you haven't already opened up the survey, here's the link. I will paste that in here.
I had it here somewhere. Oh,
And I'll paste it on the YouTube as well. If y'all want to
Okay.
participate at home. I'll even paste it into IRC. I'm just feeling that generous tonight.
I'm back. Sorry about that.
No worries.
Let's see here. What I was looking for is okay, there's a file that I have. I want to do TNT2 encrypt. And type today. Okay, and this is, again, I encrypted that and I told it to use PEM. And that's using the PEM filter that I used earlier. I told about
Okay.
it.
So it's encrypting your data and spitting out a PEM file.
Yep.
Nice.
And this counter tells it the counter to start at when it decrypts. This is not asymmetrical encryption.
Okay.
And it tells you the file name that was encrypted, whether compression was used, and the API level, which is something I use to make sure I don't try to decrypt something with a later version that I encrypted with an earlier version. But it does that. I can also tell it to compress. Using zlib. And as you can see, this is a little bit smaller. But that command line that I was talking about, COBOL, does a lot of things for you when you're doing command line interfaces. You get a help system, you get being able to do arguments. So anyway, any other questions?
I learned a lot. It's very interesting.
And
Is
like I
there
said,
is there a way to create libraries instead of executables?
Go compiles everything down to a single executable right now. You can have plugins, which are shared libraries that you can load in. But right now, I think I've never done anything with the stuff. They're coming out with some new stuff for having libraries.
Okay, thank you.
Right, but could you build like a .so file that would be called by some other language, or is that just not how? It's not a system language.
You can combine C. You can call Go from C, and you can call C from Go.
Okay, so you can embed it one in the other.
Right. You can create SO files.
Okay.
In fact, if you're using plugins, you create the plugin as an SO file that you can load and call functions in that SO file.
What would you have to call those functions from another Go program, or do you think you can call from?
Plugins are from another Go program, but you can call. You can look in the documentation. I've never had much use to do that.
Sure.
So I haven't played with it, other than knowing you can do it.
Yeah.
But I can't answer how.
Yeah. Okay.
Like one thing that I could use for plugins is the preformal loaders are built into the program, the encryption program. I can make those plugins so you can create your own.
Yes. Yeah. So your binary is smaller, and then you just suck in the plugins you want for the job you're doing.
Yeah. So the filters and stuff are all out on GitHub. They're public. So if you want to look at that.
Yeah, those are your GitHub account, right?
Yeah, it's github.com/bgallie.
Okay. Good old Bagali.
Bagali, yes. And what else do I want to talk about? The tour is pretty good. There's a lot of good learning on GitHub on go.dev. Go.dev is really the place to go to. And if you search for Golang, it's also Go is also called Golang. The reason they have Golang there is because it makes searching easier.
Yeah, just try to search for Go.
Oh, yeah. So, and you can download Go from here. You just go to the download page. There's the Apple Mac OS. There's your version for Mac. They have it for both Darwin and x86-64.
Mhm.
One question I have is, where do you see Go in about 5 years?
I see it going, and it's growing, and I see it going pretty big.
Hmm.
One of the biggest gripes I heard about Go in the beginning was, when are you going to have generics? Myself, I never saw that big a need for generics, but Go now has generics.
Really?
Yes. Like I say, I really never saw much need for it. That encryption system that I was showing you it basically has 6 rotors and 2 permutation tables. And I have the rotors and stuff are basically set into Go routines. So I have basically 8 Go routines. So when it's encrypting things, it's actually doing it in parallel because I have enough machines on here to enable that.
Hmm.
So what happens is it goes through a rotor, goes through another rotor, goes through a permutator table. But while that one's going through the permutator table, another one's going through the second rotor, and another one's going through the first rotor.
So they're like pipelining.
It's pipelining.
Yeah.
Which is, I'm doing it now in a more efficient manner than I did it when I first wrote it in Go.
Hmm.
Because I learned new things and various things like that.
How long did you say you've been playing with Go?
I would say about 5 years.
Okay. So you've been around it for quite a while. You're pretty comfortable with it. And that's why you'd probably choose Go now instead of Python.
Yeah. And I've done things like when I was working at GM, I was supporting a system in Europe that we had to look for log files.
Hmm.
And the log files were, they kept a lot of log files.
Sure.
So I wrote there was a script we had for picking the log file that you want to view, and it would show you that log file. Well, I wrote a Go program to do the same thing, except a lot more flexible.
Yeah. And that went into production? Your Go
Well,
program?
it was in use on production machines,
Okay. Well,
but
good.
it was used by the operation support people.
Hmm.
It wasn't something used by users.
Okay. But still, it was one of the tools they had, the engineers had, the production engineers had, right?
Yep.
That's cool.
So if I'm going to write something, I'll think about writing it first in Go before I write it in something else.
Okay.
Exception being a simple script pipeline. I'll do that in shell. But
Sure. Sure.
one of the reasons I wrote those filters is so I can like you said, if there's stuff that I was doing that I wanted the pipeline, I can do it. Anything else I can answer?
That's pretty cool, Bill.
Yeah, I just have a couple of comments. Number one, Bill gave me a hell of a Kickstarter when it came to my programming experience or profession. But my comment is, at what point does K&R get any credit for first Richie with his B program, and which progressed into C? And I look at the Go language, and the structure of the language is very, very similar to a C.
It's
as
similar
well
to
as-
C and similar to Java.
Yeah, and-
Yeah.
I mean, there was a lot of work back in the early '60s when it came to do we do 36-bit? Do we do 32-bit? But C came out of that's and it's still in it's still in apparently quite a
Oh,
C
one of
is,
the, yeah, it's still used a lot. But C has some disadvantages. There's no garbage collection in C.
Memory management in general is
you know,
it's all up to you.
admittedly, that is a big problem. You know, when running a C program, you have to be extremely careful on memory usage.
Yes.
Uh,
One nice
But-
thing about Go, there's garbage collection.
okay,
There's
and
no alloc and dealloc.
Yeah, so you're not calling malloc to grab memory and then release it later.
Right. Everything, when you create something, it keeps track of it, and it's garbage collected.
which is in C, you had to do that manually. You had to keep
Yes.
track of what memory you're using, and also how to release it.
And unlike Java, there's no different garbage collectors. There's one garbage collector that works very well. And you don't have to worry about, well, do I have to use this garbage collection model or this garbage collection model to get the best? That's one of the things I had to do when I was writing Java program, was worry about garbage collection and which is the most efficient for the program I had. And it was a pain in the posterior.
Yeah.
Now, and here you don't have to worry about it with Go.
Well, that's what made us worth big bucks.
Yeah, but with the big bucks came big headaches.
Mhm.
And in Go, you can't step over other people's memory. It's types, there's type safety and program safety. It's pretty safe language to write in. There's no union, by the way.
You know what?
There's no union statement in Go. There's no concept of a union. In C, you can have unions where you can define different types in a union.
Oh gosh, yeah. It's been
Yeah.
yeah.
No, it's
It's
not that they're
forever
against the
since I've-
Teamsters or anything like that.
Yeah, right. Boy, it's been forever since I've seen a union in anything.
Yeah,
But
That's just a way to redeclare a chunk of memory in a different way.
yep.
To say these two data
You
structures
can do
are.
some very interesting things with it, but you can.
Oh, sure.
In the back with it too.
Now,
Oh, yeah.
did you say Go was garbage collected or not?
It is garbage collected.
yeah. Well, the one thing that bothers me is that across the top of your display, you got free license, non-professional use, start license,
Oh, that's
Our
his
trial
Windows.
lessons are by.
That's his VS Code thing.
So,
So if you're using it for professional,
I think that's any desk is giving that message, isn't it?
but yeah, that's AnyDesk.
Yeah.
That's AnyDesk. I don't want to pay, since I'm only using it to talk between a couple machines in my home. I don't want to pay the $14 a month to get the license version. This is all at my house.
Yeah.
That's what's there. That's from AnyDesk. And I have to put up with certain things, like after so much time, AnyDesk will time out and I have to reconnect. I think you saw that me do that one time here. But the VS Code, Visual Studio Code, if you're not using it, that is a pretty good, no matter what language you're using. This is used at GM now for everything.
Really?
Yeah.
well, $14 a month is not bad. I'm paying a hell of a lot more for.
It's not bad, but for the amount I use it at home.
Yeah.
I'm going to use the free version. Sorry.
Yeah. But if you're using it for development, commercial use, at $14
Yes,
a month is,
I would pay for it.
yeah.
In fact, they have a more expensive version that I would probably use if I was using it for work purposes. It's a good tool. It's fast. I'm using it in place of remote desktop.
So it's not an interpretive language, it's you actually compile down to machine level. Is that right?
Yes.
Yeah.
It's a compiled language. It's not an interpreted language, and there's no VM.
Okay.
You're compiling to machine language.
Speaking of the virtues of Visual Studio Code, I've found more and more uses for it, besides the fact that it handles a lot of different languages. We were speaking about Raspberry Pi cross-compiling. You can have Visual Studio Code install a stub server on the Raspberry Pi, and it'll allow you to debug remotely from the desktop here onto a Raspberry Pi, which I think is really cool.
And one thing it does that I like is if I do an MD file, it will show you a preview of it. Right next.
Z80.
Markdown.
Yeah, this TNT Engine was based on a Z80 assembler program.
Uh-huh.
In fact, Z80 is one that you got me started on.
Yeah.
Yeah.
Oh, I loved the little Z80.
Yeah.
I wrote a lot of code for Z80 stuff, man.
Whatever happened to Zilog?
They're still out there.
Yeah, they're still out
Are
there.
they?
Yeah. Along with the folks that do the 6502, they're still out there as well. It's not MOS technology or anything like that, but there's a separate company that still does 6502 stuff.
But the Z80, then they had the Z8000.
Yeah.
Actually, the one microprocessor I really liked was the TI-99. TI-9900. That was the first 16-bit microprocessor I ever had.
And unfortunately, Texas Instruments did some incredibly silly things with it in the home market.
Yeah, I know.
in my early career, I spent a lot of time on TI business systems. It was I think it was like a TMS 99,000, if I'm
Yeah.
not mistaken.
Yeah.
And God, I was at one point I was doing I did a lot of COBOL code on it, but I wrote a bunch of subroutines in assembly language on that chip, and that was fun. It was the good old days.
One night about the TI microprocessor mini computers was the fact that the registers were in memory, and there was just a register pointer.
Yeah, I remember so little of it.
Well, you want to do a change of your registers. You save the current pointer on the stack and
Yeah,
yeah, new pointer.
yeah.
I'm looking at the
Yeah.
Wikipedia page for it. It says it has a TMS 9900 and it came out in March '84. Pretty amazing that for that little system, it had a 16-bit processor in '84. That's pretty darn good.
Which system are you referring to?
The TI 99.4A.
Yes, it was a 16-bit processor.
Yep. And they hamstrung it 16 ways from Sunday. So there was the TI 99, 99.4, which unfortunately so I'm trying to remember exactly what they did with it offhand, but think of it this way. Basically, they sent the instructions through several different interpreters and whatnot. So you have something like BASIC. It basically went through the slow route to get to the actual machine itself.
Mhm.
They hamstrung the crap out of
They
it.
had they had what they called was GROM,
Yeah.
which was graphic read-only memory.
Mhm.
Basically, it had code that was interpreted. It had 256 bytes of RAM, if I remember correctly.
Yeah.
And then they had an interpreter that interpreted the GROM memory.
Yeah.
Well,
No,
when you plugged in the cartridge, that was the GROM memory. That's where they interpreted that code. I actually went and bought the extra memory for it and the machine line. They had a assembler
Oh, okay.
that you could actually write machine code on it for.
Like a machine language monitor.
Yeah.
I had that for the Commodore 64, right? The MLM. Doing assembly on what was it, a 6510 processor, I think. Yeah.
I think it was 6502. It was on the Commodore 64 still.
I think the VIC 20 was a 6502, and I think the Commodore 64 was a 6510. I think, but again, that was 40 years ago.
I thought the 6510 was the one that was in the drives itself, because they actually had 6502 processors or 65,000 processors in the hard drive or the floppy drive itself. No, you're right. It is a 6510. I'll be damned.
Huh.
I will be damned.
Yeah, I still have that somewhere around here.
I think I still have my RCA Cosmic VIP
Yeah.
around somewhere.
I imagine the capacitor.
2K of memory.
I should get mine out sometime.
Yeah,
I don't think I have a TV I can plug it into though.
Before we go completely down the rabbit
Yeah.
hole of memory lane, are there any
We're
other
already there.
questions for modern systems?
Yeah, I have a question. How does that compare to Rust?
Don't know. I never really used Rust, so
Rust is a whole different beast.
I'm sorry?
I said
I've never
Rust is
used
a whole
Rust.
different beast.
I've never used Rust, so but it's one of the languages I've never looked into. And I've looked into a lot of languages in my past.
No, the reason is I'm starting up on Rust, and again, you see the origins in the C language, similar to what the Go language, and I guess I'd have to look for a comparison between Go and Rust. and
You
do
can probably search on it and find it. Just
yeah. Thanks to the web, we can find out a lot of that stuff.
Yeah.
and like I said, if you look through a lot of those talks, there's a lot of different articles on the Go Dev to learn more about Go.
Yeah.
Some-
Well, it's been around long enough to have actually have an ecosystem in a community.
Yep. There's a pretty big community and it's growing. And like I say, I like it because when it compiles down to machine language, it handles concurrency very well. It's garbage collected. It's got a bunch of different packages available for it.